I will show you a few examples. So sometimes you are in this case, you think about the setup of your study and you see no reasons for having batch effects. You make your UMAP and you don't see any batch effects at all. So the two samples behave very similarly. There's no shift between the two colors. There are no clusters that consist solely of one particular sample, so we don't see any batch effects here. So when this is the case, don't do a batch correction. Sometimes you are in this case, you see a very strong batch effect, so there is a complete shift between the two colors on the UMAP. And the clusters consist solely of cells from one of the two samples. Now, in that case, you have to think about the setup of your experiment. If the experiment was set up in such a way that you don't expect to see big batch effects, and the biological question that you're trying to answer can produce very different cell states, well, in that case, the strong batch effect that you see can be a biological effect. If you're going to assume that this is a batch effect and you're going to correct for it, while this is in reality a biological effect, you are going to remove the biological signal from your data and you will not see anything at all. So if you see strong batch effects, always think about where do they come from, and if you're really convinced that they are batch effects, you have to correct for them. However, this is an example that I got from one of my colleagues, and this is an example where this batch effect that we think to see is completely biological. So the two samples are so different that they behave very differently, and this is really biological differences that we're looking at. So we don't do a batch correction in that case. Most often you will see something like this here. So there is a shift. Yeah, you have only purple colors here. And here on this side, you only have blue and green colors. So there is a shift between the samples, but it's not as bad as it was here. Here again, you think about the setup of your experiment. If you expect a small batch effect, the samples were handled by different people. They were harvested on different days. They were sequenced in different lanes of the flow cell. So if you see reasons for a batch effect, you can do a batch correction. And here you see the result after a harmony batch correction. So the harmony batch correction is one of the least stringent ones. And you see that it removes the differences between the different batches, between the different samples. So they now all behave very similarly on the UMAP. And here you can see the danger of doing a batch correction if the batch effect that you see is biological. So after the batch correction, everything behaves more or less similarly, so you will not see the differences anymore.